Hello everyone, welcome to this session on electromagnetic fields. Today we will see examples on electric field intensity. So this is our first part of examples on electric field intensity. So we'll continue with our previous examples. Now this is our example what we were discussing. It is example 10. It reads as, if a charge of 2 microcoulomb is located at point P1 where P1 is defined as 1, 0, 0, and another charge 1 microcoulomb is located at P2 0, 1, 0 in free space. Then we have to find the electric field at point P2. The first task is to find out the source and destination. Say this is our one point P1 and simultaneously we have another point P2. They are in space. Say P1 is located at some location 1, 0, 0, and P2 is located at 1, 0, 0. So what is the source? Source is the one who is applying the force, and the destination is the one who is facing the force. So we have to find out force or electric field intensity on P2. So P2 is destination. This information we require to find out the position vector R as it is given by destination points minus source points. So our vector, position vector R bar is given like this. Okay, so this is the setup. Now this is a two-dimensional setup. Now if we want to imagine this thing in 3D, so we can consider a three-dimensional setup. Say we can take one z-axis, one y-axis and one x-axis. Say this is x, this is z and this is y. P1 is located at where x is 1, y is 0 and z is 0. So somewhere here we may get x is equal to 1. So y is 0 and z is 0, that means P1 is located on this line itself. So this is P1. Where is the P2? P2 is at 0, 1, 0. That means it is present on y-axis. Say this is 1, this is 2. So at this position we have P2. And what we have to do, we have to find out force on P2. So what we will do, we will draw one line from P1 to P2. So this vector line will have some position vector R bar, and in the same line electric field intensity is working. So by referring to this diagram, what we have to do, we have to use this. We have to use this diagram, right? So this one we will keep. This diagram we will use. Now let us solve this expression. So let us erase this and then we'll solve it. So first step is to identify the setup, how it looks in the 3D. That thing we have to imagine. Fine. So now we will solve this. So first of all, we will note down the given data. The given data is, say we have charges given. What is charge? Let say we have one charge Q, say F, some name will give Kf is equal to 2 microcoulomb, which is nothing but 2 into 10 to the power minus 6 coulombs. Then another charge, say we call it as Qt. We can give it any number. So Qt is equal to 1 microcoulomb. Its value is given as 1 into 10 to the power minus 6 coulombs. So we have the points for source and destination. So say RF points are given as only X component is present. So there we will get 1 into X component direction. And similarly, say for Qt, the RT is only Y direction component. Let us consider it as AY cap. So how we calculate the overall vector R bar? The destination points minus source points. The destination is RT. So R bar will be equal to AY cap minus AX cap. Now this is the vector R bar. If we want to calculate mod of R bar, we have to take square root of these values. So here also we have 1 square and here also we have 1 square. So it will be root 2. So what is unit direction? Unit direction AR cap is equal to R bar divided by R. So that will be given by AY cap minus AX cap divided by root 2. So this will be the unit vector. Now this one simply we have to keep in the expression. So let us see that. So now we will use the formula for electric field intensity. What is the electric field intensity? Electric field intensity is defined by Q by 4 pi epsilon naught R square into AR cap. So first let us write down the formula. So available formula we will write down. So say we have electric field intensity, which is a vector, E bar equal to, so he is applying the force, say QF by 4 pi epsilon naught R square into AR cap. So available values we will put. So E bar will be equal to, say QF. What is QF? QF is 2 into 10 to the power minus 6 divided by 4 pi constant you can keep in calculator, epsilon naught, this is also constant, and R square, R is root 2, so R square is root square. Now in this what we have to multiply? We have to multiply this value, AR cap. So this AR cap we will keep here. So what is this? This value into AY cap minus AX cap divided by root 2. So once we solve this, we can keep this 1 upon 4 pi epsilon naught as 9 into 10 to the power 9. So once we calculate it, I'll write down answer for you. We'll get E bar as 6.364 into Ay cap minus Ax cap. So this will be the value of electric field intensity for this example. So I hope this example is clear. Let us move to next example. Now next example we can see here there are three charges. Now in this example there are three charges what we have to consider. So about three charges values are given. So in that Q1 is 1 microcoulomb, Q2 is 2 microcoulomb, Q3 is 3 microcoulomb. The field due to each charge at a point P in free space is Ax plus 2Ay, then minus Az. Second one is Ay plus 3Az. Third one is 2Ax minus Ay newtons per coulomb. So we have to find out total field, that is electric field due to all these three charges. So let us see one by one. So part 1, if we see, so the location is given in the form of direction. So how we can find out? Suppose we have Q1 here. Q1, what is the value of Q1? 1 microcoulomb. Where it is present Ax cap plus 2Ay cap minus Az cap. That means here what is the value of x? X is equal to 1, comma, y is equal to positive 2, comma, and z is equal to minus 1. So this is x, this is y, and this is z. How we can find out it in, how can we imagine it in 3 dimension? We will consider one coordinate system. Here this is z, y, x. On x this point is 1. Let us change the color, we will see. Say on x it is 1. Say here we have 1. On y we have 1, 2. Here we have 2. We will project these points on horizontal axis. So at this point this is 1, 2. But it has some height. On height we should go on z axis. But z axis, it is, the value is given in minus z. So negative z axis we have to consider. So somewhere here we may have, this may be minus 1. So if we project this height here and if we go down, this will be the final 1, 2, minus 1. So this is the Q charge in space. Now due to this charge we have to find out now the field. Now this is 1 Q1. Similarly you can imagine for Q2 and Q3, right? So we can imagine them in the space. Now what we have to find out? We have to find out total field at a point P due to all of them. So let us calculate them one by one. So for Q we have this value Ax plus 2Ay minus Az. Say it will create some electric field E1. Okay, so this one will create E1. Second charge is Q2. So this is Q1. Q2 is how much? 2 microcoulomb. Where it is present? It is present at Ay plus 3Az. So let us call electric field intensity due to this one as E2. Similarly, we can find out, we will call E3. To whom we will call E3? The points of Q3. Q3 is defined as 2ax cap minus ay. So let us consider their electric field intensity as E3. So what will be the total electric field intensity? It is nothing but addition of all these three. So let us find out what we will get. So we have to find out E1, E2, and we already have E1, E2 and E3. So overall electric field intensity will be addition of E1, E2 and E3. So let us note it down. So here total E total will be equal to E1 plus E2 plus E3. So we will take sum of all of them. So E total will be equal to, say, 3ax cap plus 2ay cap plus 2az cap. How we get this? We get it after addition of all of them. For example, first one is ax cap plus 2ay cap minus second one is az cap, then plus ay cap, then plus 3az cap plus 3az cap, 3az cap. After that we will have 2ax cap, then minus ay cap. So there are how many x terms are there? This one x term is there and this one x term is there. So their addition will be 3ax cap. How many ay terms are there? Ay terms are, say, this is 1 plus this one and minus this one. So this one will go, will get this term as 2ay cap. And how many z terms are there? Minus az, then plus 3az. So sign will be positive and 2 minus 1 will get 2az cap. So this will be the electric field intensity total due to these three charges. So let us move to next example. The next example, we are given with one charge. The value of charge is 10 minus 10 nanocoulombs. So to solve this, where it is considered at the origin. Origin means the place where all three axes meet each other. This point is nothing but origin, 0, 0, 0, where x is 0, y is 0 and z is also 0. E is to be 0 at a point 3, 1, 1. Okay, if x component of E is to be 0 at the point 3, 1, 1, what charge Q1 should be kept at point 2, 0, 0. So say this is y, x, z. So here x equal to 2. Q1, what Q1, how much charge should be there here? For what? To make another point with 10 nanocoulomb, which is applying some electric field intensity. So let us solve this. Say we are given with this point 3, 1, 1 and one charge Q1 is 10 nanocoulomb. So what are the destination points for R1? R1 points are 3, 1, 1 minus 0, 0, 0. So it will be same. We'll get 3ax cap plus ay cap plus az cap. So this is the vector. what will be mod of vector, or simply r is equal to, it will be square root of 3, that is 9 plus 1 plus 1. So what we will get? Square root 11. Now this is for r1. Then we have to calculate r2. What is r2? R2 points are 3, 1, 1 minus, what we have to subtract? The source points 2, 0, 0. So what we will get here? We will get ax plus ay plus az. And what will be the mod of r2? Mod of r2 will be equal to root 3. So this is r1, this is r2. So what will be the total electric field intensity? It will be addition of E1 plus E2. So now let us keep the value and calculate it. So total electric field intensity will be addition of E1 and E2. So let us find out the value. What will be the formula? What is formula? Say E total is equal to E1 plus E2. What is E formula? Say for E1 Q1. Here we have 4 pi epsilon naught R1 square into AR cap plus. Second one is Q2 or Qt divided by 4 pi epsilon naught R2 square AR2 cap. So this is the formula. So what is AR1 and AR2? Here say AR1 cap. AR1 cap is nothing but R bar by mod of R bar. R bar is 3 AX cap plus AY cap plus AZ cap divided by root 11. And what is AR2 cap? AR2 cap is equal to R2 by mod of R2. That value is nothing but AX cap plus AY cap plus AZ cap divided by root 3. Now we'll keep these values in AR1 and AR2. So let us see what we get. Let us solve this by keeping the value of unit direction. So we'll keep the value of charges. So this will be equal to charge for charge 10 nanocoulombs minus 10 into 10 to the power 9 into 9 into 10 to the power 9, that is 1 upon 4 pi epsilon naught divided by 11 cube, we can say 11 to the power 3 by 2 multiplied by what is R bar 3x plus AY plus AZ. Now this one is E1. Now we'll write for E1. We have to plus it. We have to plus it with E2. Here charge, say Q2 will write into 9 into, this is E equal to 9 into 10 to the power 9 divided by R is 3 to the power 3 by 2 into AX cap plus AY cap plus AZ cap. So we kept these values. Now we have to solve this. So you try to calculate it on Calc. For easy reference, I will add the answer here. I will write down the steps of both the answer here. So this answer solution will be addition of this. Until I write down answer, you try on the calculator, you try to solve this. I hope you are noting down all the steps in your notebook and continuing with our next steps. So here I'll write the steps for you. Total electric field intensity simplified for this will be equal to minus 90 divided by 11 to the power 3 by 2 3 ax cap plus ay cap plus az cap plus say q2 into 9 into 10 to the power 9 divided by 3 to the power 3 by 2 into ax cap plus ay cap plus az cap. So after simplifying this, we get answer as, I will write down the last answer value. So this will be equal to minus 90 into 3 by 11 to the power 3 by 2 q2 into 10 to the power 9 into 9 divided by 3 to the power 3 by 2 equal to 0, or we can say qt or q2 equal to 4.27 nanocoulombs. So you should get this value on the calculator. So with this we will stop our session here. See you in the next session with part 2 examples on electric field intensity. Thank you. Have a good day.